Hello there, welcome back. In this video we are going to be looking at mean, median, mode, and range. We're also going to look at two new concepts called skew and distribution. So to give this page a title, let's go ahead and write mean, median, mode, range, skew, and distribution. Now, you have learned about a process in math called distribution. That is something that we talked about back in algebra. This is a different kind of distribution. So it's a different word. You have flashcards for all of these. It's very important that you keep practicing those. But let's take a look at them with some practical examples, and I think that will help you really to understand. So for this lesson, you need two of these memory pieces. They're both labeled item 36. You have one about a veterinarian, and then there's one about a final exam in biology. So I want to start with the one about the veterinarian. And that looks like this. So let's read the problem and see what we're supposed to do. The data below shows the weights in pounds of dogs that a veterinarian saw during the course of 1 week. Create a line plot of the data. Then calculate the mean, median, mode, and range. Describe the data. Is it skewed left, skewed right, or symmetrically distributed? So we need to do a lot of things here. But the first thing I'm going to do is to create that line plot. And we've done these before. Remember the examples we did about the typing class and also the science class that was measuring rainfall. We've done these, but it's been a little while. So let's take a look at how this works. The first thing, if you recall, is a frequency table that I built for that last problem, or those last problems. So I'm going to do that again. I think that's really a good skill to develop. It's a very useful skill for lots of things. So let's take a look. And to do a frequency table, you want to give it a header and 2 columns. And this is the weight of the dogs in pounds. And then this is the frequency of those weights. Were they duplicated at all? And I'm going to make some rows. We may have to add rows, or we may take rows away. We'll see what we need to do. But let's make a few to get started. I'll just go ahead and finish my table. If I don't need them all, that's okay. All right. The first weight that I see down here is 15. So I'm going to put that in the first cell of my table, and I'm going to count all the 15s. And I have 1, 2, 3, 4, 5 of them. So let's do the frequency as 1, 2, 3, 4, 5. And then I see a 40. So let's put that in the table and count them. There's 1. I just see it once. So only one of the dogs weighed in at 40 pounds. Then I see a 20. And I only see one dog that weighed in at 20 pounds. And then I see a 25. There's 1, 2, 3 of those. And then I see a 10. I just see it one time. It only occurs once. That's the frequency. And then I see a 35. That occurs 2 times. And then a 90-pound dog. That's a big dog. I wouldn't expect a big frequency on those. I see just one of those. Then I see a 5-pounder, which is pretty small. I only see one of those. I see an 18, so I am going to need more rows. I'm going to need 3 more rows, actually. So there's 1, 2, 3. I think I can squeeze it in there. So I have an 18, an 80, and a 105, and those each occur only one time. So I have accounted for all of these. I need to count. I have 3 rows down here of 6. That's 18. So 18 dogs. I need to count my tally marks and be sure that I have 18 of those. So I have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And now I am ready to draw my graph. And I'm debating, I think I'm going to put my graph outside of this graphic because I need to have some space. And you can do this too. Leave room to glue your problem down up there, but then put your line down here so that you have some room to work with. And I need to count my data points. How many different pounds were there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this line is going to need 11 of those markers. I'm going to put one right in the middle, and then I'm going to come either side, sort of counting backwards. There's 5, 6, 7, 8, 9, 10, 11. So again, I would use a ruler if I had access to one and could do that, but I don't. So I'm doing the best I can here. If you need to stop your video and make this with a ruler, that's fine. Okay, so let's put our points on here. The smallest is 5. I'm going to do 5, 10, 15, 18, 20. And then I'll go back and get the others. So 5, 10, 15, 18, 20. There's 25, 35, 40. 25, 35, 40. There's an 80, a 90, and a 105. Is that a 10? Yes, 80, 90, and 105. 80, 90, and 105. And again, I am not listing the weights in between. I only want to list weights if they were represented in my data. Okay, the 15-pound had 5. So I'm going to put 1, 2, 3, 4, 5. And you can use X's if you prefer. I had a 1 for the 40, a 1 for the 20, 3 on the 25, a 10 had 1, 35 had 2, 90 had 1, 5 had 1, 18 had 1, 80 had 1, and 105 had 1. Again, let's count the dots. Make sure that you have 18. And I won't count them out loud, but there we go. 2 and 5, 9, 12, 14, 4 more makes 18. So we've counted all of those. I made sure that I have accounted for every dog. And then we need to label. We have the weight in pounds. And we want to call this dogs in 1 week, or whatever you want to call it. Just give it a title and label the scale. So there is the line plot, or the dot plot, if you prefer to call it that. Now we need to find the mean of the data. And to find a mean, here's what you need to do. It's a 2-step process. You need to add the data. So using your calculator, and this is where that frequency table comes in handy. You see that I have 15 times 5. Go ahead and do that on your calculator. 15 times 5 is 75. Then I have a 40. I have a 20. I have 3 of the 25s, so you have to type that in 3 times. I have a 10. 2 of the 35s, a 90, a 5, an 18, 180, and 105. And I got 588 for that total. And then we are going to divide by the number of dogs. By 18. The number of tally marks, the number of green dots, or the number of dots on your graph. So just hit divide by 18 and you get something very, very ugly. It's okay. 32.6 repeating. So the mean, the average size dog, is about 33 pounds. Let's go ahead and round it up. Because you can't have, well, you could have 0.6 pounds. But I'm going to call it about 33. Now you might be thinking, but there was no dog in this visit that weighed 33 pounds, and that's right. We are just talking about an average. We're not saying that a dog weighed 33. We're just saying that that's the average weight for these dogs. So the next dog that walks in the door, I would expect it to weigh around 33 pounds, just on average. So the mean, which is another word for average, is about 33 pounds. And mean is another way of saying average. They could have you to find the average or the mean, and it's the same thing. Okay, to get the median. I'm going to show you 2 ways to get a median. The first is the classic way. You put the values in order. And then you find the middle. Median means middle. The middle value. So, I'm putting these in order. We've got them down here. I'm going to refer to this because these are already in ascending order. So I have a 5, I have a 10. I have 5 of the 15s. Then I have an 18. I have a 20. Have 3 of the 25s. I have a 35 twice, a 40 and 80, a 90, and a 105. You know what I'm going to do. Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so I have 18 values. That means the middle would be at 9, between 9 and 10, the 9th and 10th one. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. And then there would come the middle. So the middle would be right here because there are 9 values on this side. There's 9 on this side. Let me highlight. That's going to be easier. There are 9 values on this side. And then there are 9 values on this side. So the median is right in the middle of those two. It would be where that green dot is sitting. So we need to find out what that would be. What is between exactly halfway between 20 and 25? So you would say 20 plus 25 is 45. And 45 divided by 2 is 23 and a half. 22 and a half, sorry. So the median, the middle value, is about 23. You could leave it at 22 and a half. That is the median value for this data. So for these dogs that came into the clinic, the middle weight was 23 pounds. Even though none of the dogs actually weighed 23, that would be the median weight if we were to calculate that. Okay, the mode is the number that you see most frequently. So most, let's call it mode. The mode is the number that you see most frequently. And you can look at your frequency table. You can look at this graph that we made and easily tell the mode. Of this data, here's the mode, because 5 of the dogs weighed in at 15 pounds. So the mode for this data is not about, it is exactly 15 pounds. More dogs weighed 15 than any other weight. Then to find the range, I'm going to put that right down here. Range was always my favorite because I could do this one always and do it pretty quickly. Range is the largest minus the smallest. This data has a very wide range. We have 105 minus 5 leaves us with a range of 100. So this is a very wide range. We had big dogs and little dogs, and that means that the range is very wide. Sometimes range will be very tight. You may just have a difference of 2 or 3 pounds as opposed to 100 pounds. But these dogs varied quite a bit. Okay, I'm going to hold off on distribution and skew for just a minute. We'll come back to that. You can go ahead and paste, again, fold your piece in half and then stick that down so it will open up when you want it to. And let's look at another one, and then we'll come back to skew on this one. Here are the grades from a final exam in Biology 101. Create a line plot of the data, then calculate the mean, median, mode, and range. Describe the data. Is it skewed left, skewed right, or symmetrically distributed? So the first thing I'm going to do is count my students in this college class. So I have 1, 2, 3, 4, 5 rows, or 5 in a row times 3, that's 15, 16, 17. So we have 17 students in this college class. All right, let's do a frequency table. So build yourself a table here. We're going to give it a title. Not a title, excuse me, a header. We're going to call this grades. And then, of course, this side is the frequency. How often did that particular grade occur? All right, so it looks like on this exam, questions were worth 5 points because you have 5, the numbers are divisible by 5. So I'm guessing that on this test, each question was worth 5 points. So I have an 85. And let me do frequency. I have 1, 2, 3, 4, 5, 6, 7 students scored an 85. 1, 2, 3, 4, 5, 6, 7. Then I see a 95. And we had 1, 2, 3 students who did 95. Then we had 2 people who scored a perfect score. 2 100s. And then we had 2 people who scored a 65. And then we have 3 people who scored a 75. Count your tally marks. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Everybody is accounted for in my data set. Okay. All right, I think I'm going to try to draw this graph on here. That was my intention. If you don't feel like you have enough space, don't do it. Just do it wherever you want to. But I think I like mine on here a little better. So put the line down, and you have 5 data points. So we're going to say 1, 2, 3, 4, 5. And just do your best to get them spaced correctly. So we have the lowest score is a 65. Then we have a 75. We have an 85, a 95, and then that top score of 100. So these are the grades. We have, for the 85, a frequency of 7. For the 95, we have a frequency of 3. The 100, we have a frequency of 2. 65, we have a frequency of 2. And 75, we have a frequency of 3. Count your dots. 2, 5, there's 7, that makes 12. 15, 16, 17. All students are accounted for. And I'm going to call this biology test or biology finals. Okay, so we have drawn the line plot for this data. Now, let's take it a step further and calculate those values that we need. So I'm going to say the mean. Remember, mean or average, they can ask you either way on an exam, is a two-step process. You must first add the values. So I'm going to add up all of the grades, and I'm going to do it right here because that's the easiest for me to do. So I'm going to say 85 times 7. If you have parentheses on your calculator, you can do that. Plus 3 of the 95s, plus 200s, plus 2 of the 65s, plus 3 of the 75s. And I got a total there of 1,435 points. And in this case, we're dividing by 17 because there are 17 students in this class. So the average grade was 84.4. That's the mean. And you might be thinking nobody scored that. Nobody did an 84.4. And that's true, but look how many did 85. So here is where most of the students scored. And that 84.4 is awfully close to that one. So there is your mean score. Okay, the median. I'm going to come down here to the bottom to do median, and you'll see why. I am going to show you two ways on this one to do median. But let me show you the way that I showed you first. We need to put 2 of the 65s down. Remember, with median, they have to be in order. So you put them in order. Then we had 3 of the 75s. We had 7 of the 85s. So you have to put it in there 7 times. I hate median because of this. And I am going to show you a trick with that graph. But let me show you the way that you're supposed to do it. 1, 2, 3, 4, 5, 6, 7. And then 3 95s. You definitely want to use commas. And then 2 of the 100s. And you know what I'm going to do. Count the values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That fits. So if you take half of 17, that would be 8.5. So I'm going to count 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. And then on the other side, I'll start counting in from the end. 3, 4, 5, 6, 7, 8. And there's the one in the middle. Okay, so there is the median value. When they're written out in a line like this and you can find the middle, you can easily see the median. Middle. Put in order, find the middle. Now let me show you on this graph how you can do that if you prefer. You know that there are 17 students. Half of 17 is 8.5. 8.5. So I'm going to count to the 8th student on my graph. So I have 1, 2, 3, 4, 5, 6, 7, 8. And then I have 1, 2, 3, 4, 5, 6, 7, 8. There is the median, and that is an 85. So you can also find your median that way. If you prefer, I always loved it when I had a graph because I didn't have to write that list out. I could just look at my graph and find the middle one. But if that bothers you and you don't like that way, you can certainly write them out and find it with that. It'll work every time, however you prefer to do it. Okay, the mode is the one that you see most frequently. It's the one with the highest frequency. The most frequent is the mode. So if you look at the graph, you see that that 85 line of dots is tall. If you look at this set of data, you can see that the 85s are very, very common. Either way, your mode is 85. You may have no mode, and you can have more than one mode. But in this case, the mode is 85. Look at how close these are. The mode and the median are the same. The mean is 84.4. It's almost 85. The range. Remember, range is the biggest minus the smallest. So the highest score was 100. The smallest of these was 65, or lowest, you could say also. So to get the range, you're going to subtract. 100 minus 65 is 35. So the range is 35. The range is not going to be 85, but the 3 M's, mean, median, mode, are very often very close. That is not at all unusual. Okay, let's talk about the distribution of this graph. And you need to see the graph to understand and see the distribution. So if you look at this graph, do you see how this is symmetrical? This has a very nice distribution. If I were to put a mirror right here and let it reflect on both sides are the same. This has a it has 2, then 3s, and then 7s. You see that pattern is very symmetrical. It's lined up. So we would say that this graph has a symmetrical distribution. Because on that 85 line, it's almost like a mirror image on both sides. The graph is very orderly. It has a nice, even shape. It's an even distribution. And that's going to happen when you have a mean, a median, and a mode that are almost the same. When you see those 3 M's lining up, you can usually see that normal symmetrical distribution. Okay, let's go back to this one just a little bit. The dogs in 1 week, and let's talk about the distribution on this one. If I put a mirror right here, where would the middle of this one be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5. So here's the midpoint. Not the median, but the midpoint. Is that a mirror image on each side? It's not, because this guy's way tall and this guy's way short. That is not a symmetrical distribution. So we can say that this is not symmetric. I can't make that mirror fit anywhere that would give me the mirror image. And let me tell you just a little bit about skew. This one is skewed slightly. It's not a heavy skew. But here's how I would think about skew. Let's divide this graph in half. So it's going to be right there. There's the halfway point. And let's count the frequency on either side. So on this right side, the frequency is 2, 3, 4, 5. So we have on this side a 5. On the left side, we have 1, 2, 3, 4, 9 total. Okay. So we would say that it's heavier on the left. It's lighter on the right. So it's skewed slightly right. You want to go with the lighter side when you talk about skew. So it's not symmetric. It is skewed slightly to the right, meaning that it's heavier on the left, just a little bit, not a whole lot, but it's definitely not symmetric. Okay, I want to go back just to show you a couple more examples to these, where we did the dot plots and the line plots. And let's talk about the skew on this one. I won't do mean, median, mode, and range, but let's look at skew on this one. So go back to this problem about Sandy as the science teacher and those rainfall totals. And let's draw our halfway point, which is going to be right here. And let's talk about skew on this fella. Okay, to the right side of that yellow line, the weight is 3. That's a frequency of 3. To the left side, you have 5, 6, 7, 8, 9, 10 dots over here. So this one is heavily skewed. There's a big difference between the dots on the left and the dots on the right. It is heavily skewed right because it's lighter on that right side. It's over here that it's lighter. Okay, let's look at this one. Ooh, this is a pretty one. Because if I say that here is my midpoint, and I look to the left, I have 6 X's. I look to the right, I have 6 X's. And they are lined up beautifully. They have a mirror image of each other. So this is called a symmetric distribution. And I bet if we found mean, median, mode, and range, they're going to be pretty close to 60. And I'm thinking seriously about going, let's go ahead and do that. It won't hurt to practice. Now, if you don't have room to do that on your page, it's okay. Just because remember, yours were both things on one page. So if you don't have room to do this, don't worry about it. If you want to do it on scrap paper or somewhere, that's fine. But let's calculate mean, median, mode, and range for this data. And if I can, I'm actually going to take a picture of that right there because I want to be able to use that down here. So let me put this down. Well, where'd it go? Yeah, there it is. So I'm just looking at this frequency table, and if you're doing this with me on scrap paper, you might want to copy this frequency table to your scrap paper so you can follow what I'm doing. That's up to you, but you can pause the video if you need to. All right, let's get the mean. Remember, the mean is to add up all the data. So I'm going to show you how I would do that. I would say 38 times 2 plus 42 times 4 plus 60 times 6 plus 75 times 4 plus 90 times 2. So with my calculator, I'm going to do that math. No way at this hour I'm going to try that in my head. So there's 76. I wouldn't try this in my head at any hour, guys. Not my head. You may be able to do this in your head. Things just get jumbled up in my brain. And then I'll add all of those. So I have a 76 plus a 168 plus a 360 plus a 300 plus a 180 equals 1,084. And then I'm going to divide that by how many people that I didn't write it down, did I? So let me just count here. We have 6, 12, 16, 18. Divide by 18. And so the average typing per minute is 60.2 words per minute. So there is the mean of the data. Now for the median, I'm going to go with my graph. I'm not going to write all this down. So we know that there are 18 people in this class. You take half of that, that means the median is at 9.5. So I'm going to start counting here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then on the other side, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the median is right in here. The median is 60. It's in that column of 60. So we can say that the median falls in the 60 column. The median is 60. Look at that, how close those are. That is because of that nice symmetrical distribution. The mode, which is the one that occurs most frequently, most common, look at that, it was a 60. No surprise. The range won't fit this pattern, it's just the M's that will be close. So 60.2, 60, and 60, those are almost identical. But let's go ahead and find the range, just so you can see how that works. Range is the biggest, which is 90, minus the smallest, which is 38. And on your calculator, do that math, and you'll have the range, which is 52. And that's even close on this one. But usually range is something wonky. It's not gonna, the M's will hover together, but the range can be all over the place. But it's this distribution that makes that matching of the M's. If you have that nice symmetrical pattern, your M's are usually going to be really close together. Okay, this has kind of run into a long video, but we had to talk about lots of things here. Skew and distribution, and this is pretty advanced stuff. If you have questions, I would not be at all surprised if you do. Please contact your instructor. He or she can help you with this. And we are also going to do some practice in our TABE workbooks. So that will help as well. Hope you have a really good day, and I'll see you soon. Bye-bye.